Okay, I'm making this video to explain a bit on how to solve this question related to the equilibrium, because I can see that many of you are quite confused with the reaction, and some are actually not clear of the forces acting on this uniform horizontal beam. Okay, so let's identify the forces that's acting on this beam that is hinged on the wall, and it has a cable that is supporting it at a certain angle. So the first force we can identify is the tension T that I have labeled here, and there's the weight of the beam 300 Newton in the middle because it's uniform, and we have the man 600 Newton also exerting downward, and we have a reaction force from the wall. So reaction force from the wall is not just horizontal as many of you has assumed, but it actually has also a horizontal component. So we can actually resolve it into vertical component and the horizontal component. So similarly, the tension here, we can be resolved into vertical and horizontal component. Okay, so first one, to solve the tension, to find the tension support of the supporting cable, we can use the principle of moment, that we pick a point of moment at the wall. So that's our POM, because we don't want the reaction force at first. Therefore, identifying the clockwise moment and the anti-clockwise moment, which is the tension going into the anti-clockwise moment, the 600 Newton and the 300 Newton going into the clockwise moment. Okay, therefore we can form our equation. Okay, so that's our first solution, that through this equation of balance of the moment, the one caused by the tension on the left hand side, the one caused the moment caused by the 600 Newton and 300 Newton on the right hand side. So from here you can actually find the T. I'm not going to show the detail because I think you should be able to do that from here onwards. And the next thing is to find the reaction from the wall. So as I mentioned just now, the reaction is not just in the vertical direction, but it is at a certain angle. So therefore we need to find the vertical component and also the horizontal component. So to find the vertical component, it's very simple. We can just use balance of the forces, because we know that the upward force plus the upward forces must be equal to the downward forces. So since we already have the TV and 600 and 300, therefore we can get the RV quite easily. So RV can be obtained, and to get RH actually we need to use the balance of the forces in the horizontal direction. So whereby we have the force pointing to the right hand side equal to the force pointing to the left hand side, which is provided by the tension. So once you have resolved the tension into the horizontal component, which is T cos 53, then you should get RH. So together with the RV, now you can use Pythagoras theorem to get the R, and after that you can use the tangent to get the angle from the horizontal. Okay, because it is not with the horizontal or vertical, therefore you must have a certain angle and you must actually find it. Alright, so try and see.